Class, and welcome to lesson 6.4, normal distribution. This is day 1 out of 2 days spent on normal distribution. So normal distributions are observed when data like height and mass are distributed symmetrically and unimodally about the mean. And don't forget that this deals with continuous data. Okay. So we need continuous data. So we talked last day about, or a couple days ago, about what the shape is. So remember, it's a bell-shaped curve. It's unimodal, which means there's one mode right here, okay? And that it's centered around the mean or the average, which is your mu, okay? And this is your random variable, and your frequency is always on the y-axis, okay? All right. So remember, unimodal, continuous, and it's symmetrical. Okay. Here are some other characteristics that you're going to need to know. So it's symmetrical about the mean. What does that mean? There's a mirror image in the center. So if I put that down there, the left side and the right side generally equal each other. Okay. Don't forget, we need to know about that sigma is the standard deviation. Okay. We also need to know that this is symmetrical. Because it's symmetrical, the mean is also the median. So mean, mode, and median are all at the same spot. Okay? Thus, the central tendencies occur at the same point, which is the center of the graph. Okay? And it's demonstrated right here, folks, where you've got 50% of your data above and 50% below, and the mean, mode, and median are all at the same spot. Okay, just remember though that just like the exponential, this is an asymptote on the x-axis. Okay, all right. So keep moving along, folks. The total of the area under the curve is equal to 1 because remember, probability total equals 1, right, between 0 and 1. Okay, and here's your formula for normal distribution, folks. It is on your formula sheet, okay, and you just have to know how to sub in the standard deviation and the mean. Okay, and again, we'll be plugging this in using the graphing calculator. I will show you some shortcuts eventually, but please make sure you know how to plug that in. Okay, and remember, to determine the probability that x is within a certain range of values, it's the area under the curve that's calculated over that range. So remember last day we took a look at the lung cancer. Hopefully you did the between 5 and 20 minutes. We're the same thing. It's just the graph's going to look different. So instead of having an exponential curve, you have the bell-shaped curve. All right. Okay, but we got to remember how to do notation when we're taking a look at normal distribution because it's a little different. Okay, so when they give you this expression here, it means that x is normally distributed, that's what the n means, with a mean of a certain value and a standard deviation. Now remember, folks, that standard deviation is just theta, so you've got to take the square root. So this is actually what we have the variance. Okay, and it gives you the variance. So remember, to find the standard deviation, it's the square root of the variance. So you have to take the square root of that second term usually. Okay? All right, so let's take a look at the second one here. Okay? It means that x is normally distributed with a mean of 50 and a standard deviation of 4. Where did we get 4? We had to take the square root of 16 to get 4. Okay? And then you could plug those values into that formula that I just showed you up above, and you could take a look at doing that. Now we've got to explore standard deviations again. We talked about them briefly in a couple units ahead, okay? But the entire population represented is in terms of the mean and the standard deviation. So we're going to spend some time with what standard deviation is. But what we want to remember, folks, the smaller the value of the standard deviation, the narrower the curve. And that's in industry, that's what you want. You want a small range in data. So that's why you want a narrow curve. But in real life, the larger the value of theta, the wider the graph will be. Okay? And remember that Standard deviation shows how spread out your data is. So I've taken this exercise from text 425, and they talk about this rule. You're going to need to memorize the rule. It's the 68, 95, 99.7 rule. Okay, and what that talks about is saying from the mean, okay, from the mean, one standard deviation above goes this way and one standard deviation below goes this way. So 68% of your data is within the first standard deviation. Okay? The next term, 95, tells you that if we have two standard deviations above and two below, that deals with 95% of the data. And then if we go 3 standard deviations above and 3 below, that gets into our 99.7%. So pretty clear, it includes most of it. The others are these little asymptotic behaviors at the end, which account for very little. Okay, and again, the same is true on a wider spread. So this would have a larger standard deviation value, and this would have a smaller standard deviation value. But as they shrink, so do your standard deviations. Okay, so notice that for any normal distribution, 68% of the data lies within the mean minus standard deviation to the mean plus standard deviation. Okay, so that's 68%. Okay, your 95 is 2 standard deviations above or 2 below, and your 99.7 is 3 above or 3 below. Okay, so let's take a look at some data and a graph to explain how this works. Okay, so suppose data has a mean of 8.2. So mean, it's going to be right here, 8.2, and a standard deviation of 2.1. Okay, draw the graph. So we know the mean has to be in the center. Okay, and then each bar that represents a standard deviation, you're going to get used to drawing these bars. Drawing these normal distribution graphs. Each bar has a difference of 2.1. So I take 8.2, add 2.1, gives me 10.3. Okay, I add another 2.1, gives me 12.4, and add another 2.1, gives me 14.5. Okay, just remember that standard deviation equals 2.1. Okay, mu equals 8.2. And if you want to find the lower limits here, which you need to do anyway, you take 8.2, subtract 2.1, and that's going to give you 6.1. Subtract another 2.1 gives you 4, and subtract another 2.1 and gives you 1.9. Okay, so what do we know, folks? We've got our graph. Okay, we know where our mean is. Okay, our first standard deviation are those limits. Okay, so 68% of the data lies between the values of 6.1 and 10.3. Okay, now we're going to take a look at the second set of data. We have a limit of 4 to 12.4. That covers 95% of the data. And then we take a look at our extreme limits, which are our third standard deviation, okay? And included in all that is 1.9 to 4.5. So if we're saying 3 standard deviations, folks, that includes the data from second and first standard deviations. It's all in together. That's why it's so much. Okay? All right, so let's take a look at an activity, folks. You will need a graphing calculator out, so if you can grab one, that's great. If not, you can go back and do this in class after. Okay, so first thing we need to do with our calculator, hopefully you need to reset it, clear all your data. Number 2, we're going to enter the data. And this is a cool example. So this is Cadbury mini eggs. And what they're doing is they're taking a look on the production line. They advertise that they produce 43-gram bags. Okay, and it says every hour 10 bags are taken from the product line to be weighed. Okay, here are some results. So some are going to be not exactly 43.9 because guess what? Some eggs differ in size and value and coating and whatnot. So what you want to do is make sure to set your calculator to 2 decimal places. Then you're going to enter the data. Okay, so plug this all into L1. Okay, and before we can do anything to normal distribution, we got to find the mean and the standard deviation. So remember, you need your stats screen up. Okay, and remember, you go stat over to calc and you choose one variable, statistics. Okay, plug that in your calculator. You're going to get a mean of 43.86. And because this is just a sample, we're using the S at X value for standard deviation, 0.77. Okay? All right. So if we're trying to calculate now, if we're assuming that the distribution is normal, determine the masses that are each distance away from the mean. So if they're 1 standard deviation away, we know that 43.86 is our middle. So you're going to add 1 standard deviation or subtract 1 standard deviation. I'll show you a little patterning that we can follow. So you take the mean, you subtract 1 standard deviation, which is 0.77. Okay, plug that in, so that's going to be 43.86 subtract 0.77 equals 43.09. Do the same, but you're going to add that 1 standard deviation in. And you get 44.63, okay? And then you do the same patterning, but you instead of 1 standard deviation, you're now 2. Okay, so you got your lower limit and your upper limit. And last one, we do the 3rd standard deviation. So lower limit for the 3rd standard deviation is 41.55. Upper limit is 46.17. All right. Now you're going to say, great, Miss R, that's awesome, but how does that make sense? Well, let's put all these on a graph, and then it'll make more sense, okay? So we're going to sketch a normal curve, which is a distribution. So remember, what's in our middle? It is 43.86, okay? And that is our mean. Put that in a different color, okay? And then we're going to do our ones above. And ones below. All right. And folks, instead of doing the 68, 95, 99.7, we're going to break that up. So we know that between the first standard deviation, it's 68%, but we're going to break it into 2 subcategories. So instead of writing 68, this one's going to be 34% because it's half of it, and this is going to be 34%, which is half. Okay, then instead of doing my 2nd standard deviation, which is 95, I'm going to take 95, subtract 68, and then divide by 2, and you'll notice that this is 13.5 and 13.5%, and you'll see these listed as standard, as normal distribution standard deviations. Okay, then we're to the last one. So take 99.7, subtract 95, and divide by 2 for the 3rd one. Okay, and you'll find that each of those is worth 2.35%. Okay, and then the last extremities that are very, very, very small, remember it's 99.7, but you subtract it from the total area of the normal distribution curve, which is 100. So you have very little left over, and then you divide by 2, and you have 0.15% on the outsides. And if you added all those up, that would give you 100. Okay, so instead of, you don't have to memorize these numbers, just remember the 68, the 95, the 99.7, and then knowing how to subtract them. So now that you know each bar, then we can now shade in whichever bar we want, and we can then find our data probability underneath the curve. And that's where we're heading for these last examples to finish up. Okay, so it says find the proportion of mini eggs that is less than 42.32. Well, first thing I want to know is the median. The median is 43.86. So it's got to be less than that according to that. The next one was 43.09, still less than that. And the next one was 42.32. So we're going to shade that in. So that's why you're going to take this and shade this all in. You could use a dotted line or a dashed line, doesn't matter to me. So what two categories does this represent? Well, we've got one category here that's 2.35%, and the smaller category that's 0.15%. Okay? So, proper communication is probability when x is less than 42.32 equals adding of the two areas. So 2.35 plus 0.15 equals 2.5%. So 2.5% of these samples are less than 42.32 kilograms. Okay. Next one says greater than 44.63. All right. So taking a look at the next one, example 2, our middle point was 43.86, so we got to go greater than that. The next one was, sorry, I lost my sheet there. Yeah, and the last one was 44.63. So this is our start of our area, and there is our closing of our area, and it's greater than. Okay, so proper communication is when x is greater than 44.63. Well, we've got some categories to enter in. So what percent is this one? This one's 34, but we don't worry about that one. So then this is 13.5. This one's 2.35, and then 0.15. Okay, so add those all up. So 13.5 plus 2.35 plus 0.15. Add them up, and you're going to get 16%. Okay. All right. Now we're going to get a little harder. Okay, so estimate the probability between two values. So we got a lower limit and an upper limit. So when we take a look, the lower limit that we're looking for is 43.09, and the upper limit, which is here, is 55.40. Okay, so you've got to shade this all in. Okay. Communication is a little tricky on this one. So probability, so you're going to put x in the middle because there's a lower limit and upper limit, 43.09, and the upper limit is 45.4. Okay, and what do we have to add? Two areas that are 34, so 34 plus 34 plus the other 13.5, 81.5%. So that means 81.5% of the samples are within that data range. Okay? All right. So last one says, estimate the range of the masses for 43-gram bags of mini eggs. Well, when we estimate, we are going to use 3 standard deviations because it's 99.7%. So it's pretty darn close. Okay, so to find the range, you have to look at your maximum and your minimum from standard deviation. So go max, subtract min. Okay, so that equals 46.17, subtract 41.55. Plug it in, and it's 4.62 grams is the range. All right. Awesome. Okay, so folks, here is your homework for the day. I would like to see if you can do this on your own. And it's just, I think, 3 or 4 multiple choice questions. Okay, good luck with this. And if you need any help, see me in class with this. And This is new stuff, and eventually we'll be using the graphing calculator to do normal distribution, but that's coming up in a later lesson. So have a great day, folks, and hope you liked your normal distribution. Ciao.